Good morning. Actually, I just wanted to correct that. I've only been at TxDOT for 13 years. So today I'm going to talk to you about bridge manual updates. We're going to, first we're going to talk about revisions to Chapter 2, limit states and loads. Then we're going to hit on the revisions to the Superstructure Design chapter, followed by Substructure Design. So let's move on to limit states and loads. For the bent section, we revised the vehicle collision force section. So do not investigate bents and piers for collision if the annual frequency of the bridge bent or pier to be hit by a vehicle is less than 0.001. This applies only to bridges in the final condition after all construction is completed, not during construction phases with temporary traffic conditions. This applies when the roadway adjacent to the column is a bridge deck. If the bent or pier needs to be investigated for collision and the design choice is to redirect or absorb the collision load, the protection must meet at least one of the following requirements. Only design the column to withstand the collision force and shear, not flexure, and do not consider the transfer of this force to other elements such as bent caps, footings, piles, or drill shafts. Use a 0.9 load factor for all dead loads and no live load for the axial compression used in shear design. Conservatively, the shear capacity can be determined with a beta of 2.0 and a theta of 45 degrees with no applied vertical load for non-pre-stressed sections as per Article 5.8.3.4.1. Bents with two or fewer columns or bents with a lack of redundancy, such as straddle bents, require special considerations. For these, consider only one shear plane for the resistance of the collision force. And then last of all, for structures with a clear distance of 25 feet or less from the center line of a railroad track, meet the requirements of AREMA. So let's move on to superstructure design. For this chapter, we consolidated some of the sections. So for section 2, this is now concrete deck slabs on I-girders, U-beams, spread box beams, spread slab beams, steel plate girders, and steel tubs. We also consolidated section 3. So section 3 is now concrete deck slabs on adjacent frame beams, such as slab beams, double T beams, and box beams. Moving on, we added additional reinforcement options, such as GFRP bars and deformed welded wire reinforcement, dual-coated reinforcing steel, and then also low-carbon chromium reinforcing steel. We revised the deck design. We increased the deck to 8.5 inches statewide. So this means that the cover for the reinforcing is now 2.5 inches clear to the top mat and 1.25 inch clear to the bottom mat. Cover on the ends has been revised to 2 inches. We also revised the geometric constraints for overhang dimensions. The maximum overhang is 3.33 feet beyond the design section for negative moment, but not more than 1.3 times the girder depth. The minimum overhang is 6 inches from the top beam or flange edge, except for spread slab and box beams. The overhang need not extend past the exterior girder more than 6 inches beyond the flange edge. And an overhang is not required for girders and beams for the temporary condition of having a stage or phase construction joint at the top flange. We also changed to an imperial deck design. And if you're not familiar with this design method is based on a laboratory testing of deck slabs. The testing indicates that the loads on the deck are transmitted to the supporting components mainly through arching action in the deck, not through shears and moments as assumed in traditional design. So for this type of method, where applicable, use AASHTO Article 9.72 with the following exceptions. Top mat reinforcement is number 4 bars at 9-inch maximum spacing in both the transverse and the longitudinal directions. And then moving on, bottom mat reinforcement is number 4 bars at 9-inch maximum spacing. And then Last, slab regions adjacent to expansion joints are reinforced as shown on the standard drawings depicting thickened-end slab details. No additional reinforcement in end regions, including those skewed over 25 degrees, is needed. So use provisions of Article 9.73, where the provisions listed before in the Bridge Design Manual are not met. The minimum amount of longitudinal reinforcement in the mat and the top mat is number 4 bars at 9-inch max spacing. We also revised the number of girders. So the minimum number of eye girders in any roadway width is four in a span over a lower roadway with a vertical clearance less than 20 feet. Otherwise, a minimum of 3 eye girders per span is allowed. We added straight strand with debonding to text girders. Straight strand designs with and without debonding are permitted, provided that the stress and other limits noted below are satisfied. Debonded strands must conform to AASHTO Article 5.11.43, except the maximum debonded length is the lesser of 1/2 the span length minus the maximum development length, 0.2 times the beam length, or 15 feet. And then also not more than 75% of the debonded strands, or 10 strands, whichever is greater, shall have the debonding terminated at any section, where the section is defined as an increment. So just a little bit about the revision of this. AASHTO adopted new pre-stress loss provisions through interim provisions in the 2006 specifications. So these provisions were significantly reduced. They significantly reduced the number of strands, but were never adopted by TxDOT. Instead, TxDOT used the pre-stress losses from the 2004 specifications, and we did research. Just a little bit about the research. It was done at the University of Texas, and that it's the effect of new pre-stress loss estimates on pre-tension concrete girder designs. And the researchers found that the pre-stress loss provisions within the 2004 specifications were overly conservative, though relatively straightforward to implement. The 2012 provisions, pre-stress loss provisions, were found to be unnecessary, complex, unconservative, and no more precise than the 2004 provisions. So the research also recommended that we should use losses that are simple to implement, more conservative and precise, less significant of a design impact. TxDOT is adopting the losses from this research, and the use of the 2004 specifications is still permitted. The manual also gives guidance on what formulas should be used for pre-stress losses. And then last of all, there are other additions to this chapter. Spread slab beams were added, as well as spliced precast girders were added. Within these two sections, information is given on materials, geometric constraints, structural analysis, and design criteria and detailing. So moving on to Chapter 4, Substructure Design. For the foundation section, there was some information added. Design foundations to be in compression under service load 1 combination. Exceptions are permitted only when additional foundation elements and or repositioning foundation elements cannot prevent tension in the foundation elements under service load 1 combination. So for columns for multi-column bents, under the geometric constraints information, the minimum size column and drill shaft for grade separation structures is 36-inch diameter unless a larger size is noted elsewhere. Column and drill shaft sizes smaller than 36-inch diameter are permissible for wide needs only. Under structural analysis for multi-column bents, analysis and design is required for round columns supporting multi-column bents when certain conditions are met involving column spacing, column height, column reinforcement, and superstructure type. And more information is given on that in the design manual. If these conditions are not met, column design and analysis, including second-order effects, and stiffness reduction due to cracked concrete is required. For detailing, for non-contact lap splices between column and its foundation, meet the requirements of Article 5.11.5.2.1. We also added information for single column vents or piers, and that information includes information on materials, geometric constraints, structural analysis, design criteria, and detailing. So now we're going to hold off on questions till Amy presents.